Thank you very much, and I would like to thank Steve and Taiwan for organizing this session. Well, I think this presentation has been made in the past a number of times, and some of you may have heard about that. I tried to add some more slides and some more insight for that. How can I move this one? Okay. First, I'd like to acknowledge the other people contribute to this presentation as a large team from different institutes in China, try to understand, identify the current challenge, and also to plan for the future research in this field. We see now Beijing, not only Beijing, China, have an urgent need to improve the air quality, not only for our daily life. It's a lot of international events has caused a reason for us to take extremely action. Unfortunately, not this Beijing International Marathon, but we know the epic blue that during that period we have done a lot of things for controlling air pollution. But we also heard about talk previously. We have been experiencing quite frequently episodes. Each episode when it's coming usually has cover a huge area in China, millions of square kilometers, last weeks long, and concentration can be as high as 500, even 700 our mean microgram per cubic meter. So this is severe pollution, impacts on huge population, and how to deal with that. One example now, Beijing in China, 2013 released first time the monitoring of PM2.5 around the country. Among the 74 monitoring sites, only 3 meets Chinese ambient air quality standard. This is the most relaxed one according to WHO's ambient air quality guideline. And we look at Beijing, and we see extremely clear during the winter time, very high PM concentration, and what's the reason for that? And the models can calculate all the emissions, able to reduce them. This has been a big challenge for us to think about that. Now, in dealing with the challenges, there are 3 R's we have to talk about. First, what's the risk? People concerned about the health. And second, what's the reason we heard about air pollution getting worse? It's really getting worse. And if with the model forecast the controlling measures be able to control them, that's the response. So for the risk, we heard about presentation today that particulate matter can cause a health effect, not only respiratory, but also vascular system and even brain or our whole body was influenced by that. And the most recent estimation of global burden disease provides that globally we have 3.2 million of people premature deaths, and ambient particles rank 7th in the risk factor. Come to China, it's more than 1/3 of global premature deaths. It's 1.2 million happening in China, and it's ranked 4th risk factor for the death. So this is a very important number for us to concern about. But behind this number, how this number came out, this is a big uncertainty with that. This is the curve we call the dose response relationship. People use like the study in US in the lower end that will have annual mean concentration of PM up to 50 microgram per cubic meter. And in China, most of the time we see between 50 to 100 micrometers. And in that area, we don't have much study on epidemiology study about the risk factor for that. Now people try to build a curve to combine the smoking, using the smoking convert the dose of PM2.5 and try to fit a curve, and in between we see there's large gap for that. This is associated with extremely high uncertainty, and it is also nonlinear with that. So how can we reduce uncertainty? I think is a big challenge for the people doing the epidemiology studies. And we know particles came from a different source, different chemical composition, and different size. And different chemical composition supposed to have very different toxicity. So always come the question, we use the PM mass concentration to estimate this health relative risk. We can always use that, or is in the future, should we more rely on chemical composition? And this could also come to the different source, could have different health impacts, and came to the policy priority to control which source has the most severe health impact. But until now, this is not much encouraging news there. Scientists put the toxicology study and epidemiology study, they couldn't find consistent evidence that different chemical composition could cause different health effects, especially with epidemiology studies. So what's the reason behind that? Suppose from toxicology they are very different. Why epidemiology couldn't provide this robust evidence for that? Well, we did some study with school children to look at a small panel of school children. And from this study, we do find that black carbon can account the most of the health impact of PM. By looking at the different design, we found that the inflammation in the school children, that's the nitrogen oxide, is clearly responds to the exposure to the black carbon, and this is percentage is a major part of PM 2.5. And also do some lag effect to see indicating that black carbon exposed in the previous hours could have different impacts and could last 10 hours. And we so-called two pollutant model to suggest that black carbon has the most robust association with this inflammation, but the PM is not. So this is one of the example to see we can, if we design the epidemiology carefully, we should be able to identify certain chemical composition be associated with health effect. Well, come to the size, we know particles could penetrate in our respiratory system, and they could cause deposit in a different fraction, different parts of our tracts here. And larger coarse and very small particle will remain on the upper part. Only in between a few nanometers to a few hundred meters would get deep in the lung and cause getting our body in the blood system. So that's indicating different size could have different health effects. There's some studies suggest it is there, but I think in general we still lack of evidence. So in that sense, in China, when in the future we want to identify key pollutants, key source contribute the most to the health effect, we should not simply rely on the relative risk. Now we generalize from the just smoking and the lower-end exposure in the US or European countries, but we have to do study to identify what's happening in the range in between, and also which source and which chemical composition costs the most. So this is one of very important risk concern. And come to the increasing people impression that air pollution is getting worse because so we heard so many news coverage. Is that really true or not? People use this haze day to indicate, some looks like true. If we compare to 20 or 30 years ago, the number of haze days are increasing associated with CO2 emission. So that is one of the indications that our emission is responsible for the air pollution levels. But if we look at the emission change pattern, we see clearly we have very diverse change. SO2 reached the peak in 2005, but the other pollutants like NOx and the VOC still increasing, while the primary CO and the black carbons remain constant. So different change of the trend of the emissions, what's the implication for our current modeling, chemistry, and also controlling measures? That's the one question we have to answer. And the other things came to the meteorology. We know that it's play an important role. And we heard about this a number of presentations, including Xiaolu's presentation, to see that the wind speed actually is decreasing, and while the haze number per year are increasing. So is the reason for we're seeing more haze days? Well, why the surface wind is decreasing? There's a different hypothesis there. Now, we know talking about the climate change or global warming or weakenings of the Asian monsoon, but there's another possibilities. Urbanization could be also the reason. We did a study, used urbanization in 1992 compared to 2006. We see clearly that compare the wind speed that's observed, this black dot, and this is urban surface area in 1992 and 2006. Definitely, if we consider the change of land surface urbanization, wind speed actually is one of reason decrease caused by urbanization, but it cannot explain all of them. And also, this is only happening in the cities. Maybe outside cities, maybe the global warming could be reason for that. And we also heard about this kind of sawtooth-like pattern up and down, and we heard about this Siberian high as responsible for that. People doing some different kind of estimation and use cold front with another indication. And we see the last 10 years, 20 years, even 50 years, we see slightly change of the decreasing of cold front numbers. Would that be reason for we have less favorable weather for the air pollution or air quality? This is something I had to think about. And there's also about the chemical reactions. We know that there's unknown so-called recycle process happening in the high VOC end area. We couldn't get high enough OH radicals with models to have kind of unknown recycles. But how about this when we're in a very polluted high NOx area? We don't know that. And the model couldn't reproduce high PM episode in January 2013 with people trying a different model considering the heterogeneous reactions. But we don't have strong lab study to support for that. So this is an important challenge, how to look at a lot of high level of pollutants in the air. What's the chemical reactions there? Are we model to be able to reproduce them? And beyond that, we have also regional air pollution traveling, and also this kind of biomass burning in the summertime, in June and in October, could contribute to that. And this contribution of biomass burning, when it's reaching into the city, could contribute to the boundary layer, changing the radiating balance, and maybe suppress the surface radiation and keep the upper level warmer and form an inversion layer, and this is unfavorable for the dispersion. And how this interaction within boundary layer, biomass burning, black carbon, and pollution accumulation is still, we don't have tools to carefully understand this process like this. And Chinese government taking air pollution control seriously. So for the first time, Chinese government in 2013 released the first national air pollution control action plan, has setting the target to control in the major area to reduce the PM 2.5 by 15 to 20% within 2 or 3 years. This is a very ambitious plan, but some looks like it's hard to reach. One big challenge is in the past, we just controlled the SO2 in China. Now we're talking about all these kind of volatile organic compounds, primary particles, VOCs, ammonias, and etc. How to control all of them at the same time. And in the past, we just controlled from the emission. Now we are control more like the risk management and how to evaluate this risk with all these tools as another one. And finally, we're talking about air pollution regional transport between the regions, how to setting or target, how to plan coherently controlling targets, and how to provide a platform, provide consistent monitoring and modeling system to ensure the regional pollution control that's essential for the success of the policy. So in summary, if this national action plan is going to work, it's going to be the largest air pollution control reduction in a short time. It's one of big experiment for us as academic scientists. If we are able to achieve that or not, I think it's a big challenge for us too. Okay, thank you for your attention. Maybe not.
Yes, please.
So in your talk, you mentioned about total emission in China's annual trend. Could it be possible that a special distribution change also contribute to the more hazy days in China?
Well, that's definitely possible, and the different sector, not only the region, but the sectors also cause a different impact. So when we come to the controlling policy, we have to rely on a lot of scenario analysis to get it more to the point. Yeah.
Thank you.
Thank you.